Hello everyone. So we'll start this week's content with the clustering algorithm that we that is this week's content. Let's see how many people have to. Yeah. So before starting the session, I'm audible, hopefully. Yeah, before starting the session, last weeks in the last week we did some things, right? Yeah, so last week I think that someone asked like how this things works, like if 1 and 2 are parents of 3, then so 1 and 2 are like co-parents of 3, then given 3, how 1 and 2 will be dependent. So I tried to find a possible explanation. So one possible explanation is that in a Bayesian network, we generally write the probability value like this: probability of 1, 2, and 3 is equals to if there is no parents, you just write its marginal probability. So probability of 1, probability of 2. If there's a parent, you just write probability of 3 given 1 and 2. So if 3 is given, so the question was if 3 is given, which is like if A, B are independent if C is given. So in this case, like if I replace A with 1, B with 2, and C with 3, so the corresponding statement would be if 3 is given, 1 and 2 are dependent. So this will translate to something such as like if 3 is given, probability of 3 given 1 and 2 will be 1, right? It will be 1. Hence, probability of that implies probability of 1, 2, and 3 will be equal to probability of 1 into probability of 2 only. And this statement says that this is not independent, because in independence, the independence hold when probability of any 1, 2, 3 will be probability of 1 into probability of 2 into probability of 3. So since this is not equal to this is dependent. So we'll come back to the clustering algorithm. Um, take some time to look at the question given here and try to answer it. I'll discuss that briefly. A and C. Okay. A and C is correct answer. Yeah, I'll explain the k-means algorithm altogether and this solution to this question as well. I think there is no more questions regarding the k-means, so we'll try to cover the k-means as much as possible in this question because k-means is a popular algorithm and it should be um, discussed in um, detail as compared to other algorithms because k-means is a bit important. Yeah, there is some programming question today as well. I'll try to solve that. Okay, so sorry, yeah, so k-means algorithm is not particularly a sophisticated approach to image segmentation task. Choose the best visualization from the below. We support the claim. So when we talk about k-means, so what happens is that so now we're looking at clustering algorithms, and the way clustering algorithms works is that let's say you have a data set with two features x1 and x2. Let's say there are certain points in the data set with some value of x1 and some value of x2. Let's say this is one point and this is another point, and the some points around it, and let's say another sort of. So these are all x and x2 values, and we can plot it like this similarly. Okay. So what k-means clustering says is that you have to first choose how many clusters are there in this uh, data set, and based on the cluster it will give you the so if based on the number of clusters that you have chosen, it will give you the clusters as a return, right? So the way k-means clustering works is that you have to find so let's say you fix a k equals to 3. That means you are interested in finding 3 clusters out of this data, and it will first randomly pick three uh, it will first randomly pick 3 points to be the mean or the center of the cluster, and each point, let's say for any point belongs to the data set. Okay, for any point p belongs to the data set, we'll find the distance 1, that is the distance to the distance between the point p and the center c1, and we'll find the distance between the point P and center C2, distance between the point P and center C3, and we'll take the smallest out of it. So we'll take the minimum out of it. So we'll take minimum of this will belongs to the cluster I, the cluster, the corresponding cluster. Okay, so minimum, we'll take the minimum, and the corresponding cluster will be the corresponding cluster will be chosen for that. So what we'll do is that we'll start assigning all those points into 3 clusters or 7 clusters, and after assigning all those things, we'll reevaluate the mean, and then we will, after reevaluating the mean, we'll then recalculate this cluster, recalculate this distance, and reassign them. So now the point might change or stay the same, but we'll reassign them, and after doing this thing for a few number of iterations, we will end up in a state where we'll have 3 clear, almost clear clusters, and with 3 different cluster centers. Okay. Another question that says here is that in an image segmentation task, so in an image segmentation, what we do is that, let's say there is an image here, okay, and there is an image of cat, let's say, okay, and there is a, let's say, house in the back, and there is a sun here, and there are grass here in the ground. Okay, so image segmentation, what it does is that it sort of creates different masks in the image. So it will put some mask here. Okay, it will put some mask here. Okay, and similarly, it will put some mask on the grass. So image segmentation works like this. So it will segment the different portions of the image based on their type. So it will try to so similarly there will be segmentation for house, and there will be segmentation for sky. Okay. So sky will be a different segment for the algorithm, and finally the sun would be another segment. Okay, so image segmentation task is that given an image, we have to find different patches or different segments in the image that are different from each other. So you can consider this as a clustering algorithm, where we are clustering clustering the points that belongs to the same object. Okay, so in the image, we are sort of trying to find the pixels that represent the same object. Right? So it is saying that k-means clustering is not a good way of doing this task, because option 1 is it takes no account of the spatial proximity of the different points, and second is the curse of dimensionality doesn't affect the performance of k-means algorithm, as it effectively handles high dimensional data with minimal loss of accuracy. Third is that the algorithm requires the number of clusters to be specified beforehand, and fourth is initialization does not affect the k-means. So thing is that the correct answer is A and C. The reason is that so the reason for option A is that so I'll just mark it. So it's A and C. The reason for option A to be correct is that k-means clustering do not take the spatial proximity of different pixels. Like, let's say this is grass, this is grass, but this is not grass. Okay. So what will happen is that so this yeah, so these pixels, since it is grass, so since this pixel is grass, the neighborhood of this pixel is likely to be more grass. If you take a pixel here, the neighborhood is likely to be more grass. But if you see in this data, even if the center is here, let's say, a point that is closer to this is a different class than a point that is very far away from this. So it's sort of the spatial proximity is not taken into account while designing this k-means clustering. So that might lead to poor performance. And second reason is that the number of clusters. So given an image, so this image has like 1, 2, 3, 4, 5 elements. There will be some images which will have, let's say, 10, uh, 10 segments, right? So in that case, we don't know that we don't know the number of clusters or the number of regions that we need to classify. Hence, this is not a correct, like, efficient way of designing, because we cannot design the algorithm to give us we cannot run the algorithm for each image to give us the uh, this segment map, right? So this is the reason A and C are correct. Okay? This is a bit I explained it a lot because this is the only question. Yes.
This DB scan is the other one, right? Where we have more spatial thing which is utilized.
Yeah. So in general, if I'd say, like, none of these methods actually we are using it today. Okay. It's just that so there is DB scan. There are a lot of more algorithms has evolved recently, which takes care of the segmentation thing, and I think this is for the beginner lecture. So I mean, this is just, it is not possible to do it. It's not very efficient to do it k-means clustering. But when it comes to which method is useful for it, there are a lot of methods which are useful for it. So not just DBScan, there are a lot of methods are there which are which will. Yes.
There was one more shift or something which was quite popular, right? SIFT.
Yeah, there is shift. There is, but all those things are like pre. Sorry, I think I muted you. Yeah. So there are like a lot of so shift and hog features. Hog
Okay,
feature extractor,
okay.
HOG. Yeah,
Okay.
shift and hog. All those are like pre deep learning era, which is like 15 years ago.
Okay.
So after the deep learning, all those things are not, almost not using. So
Okay.
today's method is foundation models, which are mostly based on transformers and um, uh,
YOLO and all that is being used now.
yeah, the foundation models. If you search it,
Foundation model.
and
Okay.
there's something called SSIM.
SAM to
SS.
Facebook.
There's something called SSIM. SSIM is not SSIM. Segment anything.
SAM, right? Segment anything model too.
Yes, yes, SAM. Yes. So those things are used. So all these problems have been fixed very early in this in the literature. But these are like basics, so it's better to know them, how things worked and how things evolved over last 20, 30 years. So coming to the question number 2, try to solve that. I'll just get someone in the door. So you try to solve this. Bye. B. Yeah, so I'll solve this question. So hope I'm audible. Yeah. I'll solve this question. This is like very easy. So they're like pairwise distance between 6 points given below. Which of the options shows the hierarchy of the clusters created by single-link clustering algorithm? So you just note this thing, single-link clustering algorithm. So if two clusters are there, then you take the closest two links. It is single-link clustering algorithm. If you take the farthest 2 point, then it is complete list clustering algorithm. If you take all the links and take average, it is average link clustering algorithm. And finally, wait, what's the fourth one? Fourth one is yeah. So if you take the center and join it, it is center link clustering algorithm.
Single link means the shortest distance, is it?
Shortest distance, yeah.
Okay.
The distance between the two clusters is the minimum distance between the member of the two clusters. In the complete link is the distance between the two clusters is the maximum distance between the two members of the two clusters. Okay. In average, you take everything and centered. Okay. So it is asking the single linking clustering algorithm. Okay. To do that, first you need to find the shortest distance. So first you need to treat all the points as shortest, all the points as different clusters. So then you need to look for the closest to clusters. So if you see P1 to P, so if all these things are clusters, so distance from P1 to everything. So the minimum is P2 is the minimum. Okay. Then from P2, so from P2 P3 will be minimum. So P1 will be minimum because it's just opposite, right? So P2 we can skip. Then from P3, P4 is the minimum because in this row. So there is 0 across the diagonal. So um, so self self clustering is the trigger solution. Then so P4 is done because we have already chosen P4. Then if you go to P5, then in this case 2 here. P6 is the minimum. So what you have to do is that you have to start with P1, P2, P3, P4, P5, P6. Okay. So P1, P2 will make a cluster. P3, P4 will make cluster. P4, P6 will make cluster. Okay. And so now you have to find, let's say, a distance between. So now distance between P1, P2 cluster and P3, P4 cluster, right? So this is the distance we need to find between P1, P2 and P3, P4. So we need to find the distance between closest to point. Okay. So the closest to point is that. So if you go to P1 and P2, find the distance from P3 and P4. Okay. So P1 to P3 is P1. Okay, so I'll just erase this. In a second. P1 to P1 to P3 is 8. P1 to P4 is 9. Okay. Similarly, P2 to P3 is 9. P2 to P4 is 8. Okay. So which is the closest one? So if you look at distance of, sorry. So if you look at distance between cluster 1 and cluster 2, this distance will come out to be how much? 8 or 9?
Closest distance, right? 8.
8. The closest will be 8, right? So, okay. So how 8 and 9 can we explain again? Okay. So we are trying to, so let's say now, by considering each point as a different cluster, we got this relation, like P1 is closest. P1 is closest to P2, P3 is close to P4, and P5 is close to P6. Now you have to find the distance between two clusters. There is P1, there is P2, there is P3, there is P4. Now you need to find these distance. But you don't know if it is P1 or P2, or you don't know if it is P3 or P4. Now you have to find the closest to point in these two clusters. So the closest to point can be found by find the distance between this point to this point, this point to this point, then this point to this point, this point to this point. Then you have to find the pair which has the closest distance. Okay, shortest distance. So if you do that, the distance between P1 and P3. Okay, so this is the what happened? Nothing. Hello, I think it's audible now. I got reconnected to the net. So given this, now you can say that the distance between this cluster and this cluster is 8. Okay. Similarly, if you find the distance between P1, P2, and P5, P6 it would be, so if I go here, P1, P2, P5, P6, right? So P1 to P5 is 5, P1 to P6 is 4, P2 to P5 is 10, P2 to P6 is 9. And shortest is between P1 and P6, that is 4. So this will be 4. 4. And the final one is distance between these two, P3, P4, P5, P6 will be equals to 3, 4. P3 to 5, 6, right? 3 to 5 is 6, 3 to 6 is 7, 4 to 5 is 7, 4 to 6 is 8. Shortest is 6. This will be 6. So out of these 3 distances, okay, you see that 4 is the smallest distance, right? So hence P1, 2 and P5, 4, 5, 5, 6 will be connected. Going to like this, okay? And so now there's finally 2 clusters, and we just connect. So the thing is that the way we need to orient this should be different. So it should be like P1, P2, P5, P6, P3, P4. This will come like this, this, like this. Same thing. And this is option B.
Sir, that first step, can you just explain once more, like how you connected P5, P6, P3, P4, and P1, P2 initially?
P1, P2, P3, this one, right?
Yeah, first step.
You take the distance of, you have to find the clusters which is closest to P1. So you have to go to P1, you have to go through the row and see which is the closest one. So 3 is the shortest distance, and 2 is the P1, P2 are the closest.
Okay.
But 2, it is give. So if 1 is closest to 2, 2 will be closest to 1 as well, because and the vice versa, right? So 2, if you go 2 also, the 2 into 1 will be the closest. Okay. And similarly,
Okay.
3 is 4 is closest. Similar. So I'll find different clusters. Let me see something in the chat. Yes. Okay. So next question. So this question is almost clear. I'll face the next question. This question is easy. It's the same thing, but a different. Okay, I think I might have. Okay. The next question is for the pairwise distance matrix given in the previous question, which of the following shows the hierarchy of the clusters given by the complete link clustering algorithm? And here you have to find the maximum distance. Okay. So you can look at this table and you can take a snapshot of this, and then you can look at the table and try to solve that.
Can you show the table?
Yeah, but still. Let's see. Okay, we'll solve that for this question real quick. So you have to find the maximum, right? So first you write all those things such as P1, P, P1, P2, P3, P4, P5, P6. And step one would be to connect those things, right, to the individual clusters. It will be same as the previous question. P P1, P2, P3, P4, and P5, P6. And since the yes,
we have to take the maximum values, right? Complete link points.
no, yeah. So in a cluster, we have to take the maximum value.
Then how P5, P6 came? P1, P2. Can you explain that, please?
Where, P1, 2, 5, 6. P1, 2, 5, 6. One, two, five, six. So 1, 2, 5, 6. Max minimum. So it's like the minimum distance in the maximum distance. But um, so when we're like doing the clustering, we still have to find the closest point, right? But given the two clusters, uh, we have to check uh, the farthest point on these two clusters. So we are minimizing the maximum distance between the two clusters.
Okay.
Okay. So since the cluster are individual, so maximum distance between two clusters will be equal to the distance between the two clusters.
Okay.
And with that logic, so that will like P1, P2, P3, P4, and P5, P5, P6. I think that logic is fine. So then you have to find that if this distance between all these points will not take much time on this one. P1, P2, P3, P4. So distance between P1, P2, P3, P4 would be P1, P2, P3, P4 would be 9, right? So it's 8 and 9. This one will be 9. Similarly, distance between P1, P2, P5, P6. So will be 10. And distance between P3, P4, and P5, P6 would be 8, 6, 7, 8. It will be 8. So since we are minimizing the maximum distance between the, so since we are minimizing the maximum distance, we're minimizing the maximum distance, we need to, so this should be the clusters like 3, 4, and 5, 6, and finally connected these two clusters should be like, then D should be the correct answer, right? But in the solution they gave me that B is correct answer, but I don't have any explanation for that. B which is same as the previous one. So I'll try to find what is the explanation for that, because it's just the answer. So I'll try to see, but ideally it should be D. Um, there is another question. If so there is one direct message. Will the exam contain MCQs like this? We don't control the exam, so exam is done by the NPTEL people who just do the tutoring. Okay, so question number 4. Okay, so there is a question number 4, but apart from that, there are 2 programming questions. I'll try to do the programming questions, 2 programming questions, because it's a bit of interesting. So I'll try to stop share here. Stop sharing. I'll share the screen here. Yeah, laptop. Wait, I'll just set it up because I'll. Okay, so we have the question about the bridge algorithm, and the question says, let me copy paste the question as well. The question is like this. In the following, so we are the question. Okay, so we have to download the dataset from here. I'll ping the link in the chat. So you have to get the dataset from here. Then you have to okay. So I think this link is like this. So you have to get the data set from here. Okay, and after loading the data set, you have to use the um, question. You have to use the bit algorithm to find the number of clusters. So find the what is the rand index obtained for the bridge algorithm. So you try to solve this, and I will solve this one in a while. I think this n clusters. Okay. So yeah, so you can try it right away on your system, or you can try it in the Google Colab. sorry, I was okay. So we'll solve this programming question. So it's very trivial. So the thing is that you can load all these things from scikit-learn, okay, and you can easily do this. So from okay, the data sets load iris, and from sklearn.cluster load bits. So you can just do the clustering, and sklearn dot matrix import and score, I guess. Score, yeah. Just give the suggestions and do the thing. So you have to load the iris data using the load iris function. Then you have to define the bridge clustering, and since the number cluster is 2 and threshold is cluster is 5 and threshold is 2, and you can easily define that. Then you have to find the features and the labels. Okay, so okay, so let me write one step here. So get x and y. So iris data is my x, and iris target is my label y. Okay. Then you have to fit fit the model. That means you have to fit the model with the data. So now you just will have to fit with x. Okay. So you have to find the predicted cluster levels. So predict the clusters. Just predict x. I can do this in this way, like a random index thing. Okay, I'll give you the options as well. Wait.
What's the difference between fit and predict?
Fit is to train.
Okay.
And predict is to predict. You can also directly take the labels.
But you are passing existing label only, yeah?
Yeah. Let me put it.
So are you segregating?
Wait, let me put the images, then I can tell.
So burst shot predict why it should be, right? Iris dot target.
No, predict. So model is ready. So model is a function, right? So it gets trained using X. So since it is a clustering algorithm, no labels will be used. When we are doing the prediction, we have to do this thing. We have to, okay, so when you are doing the prediction, we have to find, given the data, what is the cluster. So in the supervised learning, it would have been given the X, what would be the Y. Since it shouldn't be called the Y predict, to be specific. Yeah, the cluster labels, which is not actual the labels, it's like the cluster. So they're not like supervisingly doing this. So it is a on supervised data set. That's why we are using these labels. But in general, we don't actually have labels. So
Just trying to understand, like that iris.data and iris.target are test and train and test sets, right?
No, no, no.
No.
Iris.data is the features and iris.target is the label.
Oh, okay.
So you train with the features and you predict with the features as well. You get the labels.
Okay.
And let me run this. Okay. So run it using Python, the file name. Okay. One second.
But for me, it created only two clusters. Is that correct, or you should create 5 clusters?
Let's see. It's running. Okay. Okay. So is option B is the correct answer because we are getting the rand index to be 0.71 and here it is 0.7. Okay. You were saying something? The class number of cluster.
I tried to plot it, that matplotlib.pyplot
Okay.
plt,
What?
and then plt.scatter I tried. So it was showing
क्या
like
क्वेश्चन रहा नया सब्जेक्ट
it was showing
డిఎస్
like two
మాకు మధ్య తెలుసు
clusters.
యాదని ఎదుగుతావు మాకు అది ఎట్లా ఉంటుందో తెలియదు కూడా తెలియదు కోడ్ ఇంకెట్లా ఎతికేది ఏ
Hello.
Hello. Hi. Sorry. Yeah. So what did you do? You plotted.
Yeah, that matplotlib.pyplot I used to plot. Import matplotlib.pyplot as plt.scatter.
Yeah, what did you plot?
That x colon comma 0 colon comma 1. I just got it from online.
Yeah, so there are two clusters coming, right?
Yeah.
Yeah, so threshold is 2, right? So that's why maybe it is coming to.
Okay.
Okay, so I'll go to the next question. The next question is right here. So I just took the photo. Run PC on iris dataset input features with n component equals to. Now run db scan using db scan on both original features and the PCA features. What are their respective number of outliers, noisy points detected by db scan? As an extra, you can also plot the PCA feature on a 2D plot using matplotlib.pyplot.scatter using parameters equals to y spread to visualize the cluster outliers. So okay, so it's saying that first you do this with first you do the PC on the features. PCA will give you a reduced number of features, and now it will give you two features. Okay, the PCA will give you the dimension where the data is varying the most, and it will reduce the dimension to 2 from 4 because in iris we have 4 features. Now, okay, someone is writing. Okay, now then run the db scan. Okay, with this setting on the original feature on the PCA features. Then find the number of outliers, noisy point detected by db scan. Then also we can plot the things, right? So this is a question. I'll directly do the coding for this. PCA.py and here let me paste the code as well. Okay. So, and the PCA features are the number of points detected by db scan. As an extra, you can plot the vector, the cluster outliers. Okay. So first we need to do the same that we did in the last thingy. So we have to do this. So we don't need the bits now. We can delete this. Sorry. Import a bunch of things. Okay. We'll load the iris data, which is straightforward. We'll get the X and Y. Okay, so first we'll do the PCA. Okay. PCA is so first we have to define the PCA. So first is PCA. So PCA is equal to PCA and number of component equal to 2. It's very simple. You define the PCA, then you fit the transformation with X, and you'll get the X PCA. I mean the transformed X. Okay. Now we have X and transformed X, and we can run the DB scan on the original feature and the PCA features separately. Okay. So DB scan clustering on original features. Okay. And this is the parameter that are given at 0.5 and almost have 0.5. It's DB scan, and we will fit the DB scan. We can do the fit, then dot levels. It will give me the levels, or we can do the fit predict, directly it will give the, it will fit and predict the thing. And then we can do this outliers. We can do the outliers in this while prediction. You can print the while prediction. Print y pred. So let's just run this. Okay. Python pca.py. It should be renamed to db scan.py, right? This also db scan. Thanks. Python db scan.py. So outliers are given by -1, right? Okay. So now we will do the db scan on the PCA features. So we'll define another db scan object and we'll do the fit predict on that, and also we'll get the outliers on the same and print both the outliers. As simple as that. You just need to do the whatever it is said. So number of outliers in the both cases 17 and 7. Right? If you go to the question, there is an option B that says 17 and 7. We'll do the extra step as well. We can plot the PCA feature on the 2D plot using matplotlib.pyplot.scatter with parameter c equals to ypred. How this type of question can be solved in the exam? This type of question is not gonna be asked in the exam, I guess. So we are good to go. So for plotting the scatter plot, you just have to do the do this and c equals to ypred PCA. So we're just putting the scatter plot using ypred as a okay, wait. Oh yeah, ypred as a parameter, so that it will give us different color for different clusters. Okay. So there is this. I'll save this figure. I'll save this figure and so db scan. So db scan. So this is the result that came for this code. So there is one cluster, there is another cluster, and these are the outliers that is given in the violet. Okay. Coding is not a problem now. You just have to understand this, and the rest of it will be done by the AI. So just have to understand what are these things and how to. So what I'll do is that I'll try to paste this code in a paste bin and share you the links for that. Listen. Yeah.
Where this example will share it, it'll be there in the Google Drive.
No, I'll share the link. So there is one, and I'll do the second one. I also posted all those things in the notebooks as well. The notebooks that is already shared with everyone. You can find the notebook as well. Right. These are the last two questions that we're gonna solve today. Okay. If you have any doubt, okay, sorry. Yeah, you can ask. Otherwise, we'll close the session for today. Okay, we'll close the session for today. Okay, I'll see you next week. Bye.